So this is a super fresh talk. I made the slides during the call. I finished the slides, so hope you will like it. It's about approaching Web3 with Aqua language and how Aqua language and Fluence in general can help. So it seems like we're in the middle of transition from Web2 to Web3 over the last years. And it seems like peer-to-peer is the next generation of internet computing. And these generations change periodically. So around 20 years ago, we approached Web2 with cloud computing platforms, and all the mindset, all the setup, all the tooling around that evolved to use it efficiently. And we have a lot of products like the one that we're using right now, which emerges from this setup. And now probably we are switching to Web3, but let's discuss why we're doing it and what does it mean. And let's discuss it in comparison. Web2 and Web3, what we had, what we have, and why. So first of all, let's speak about the common Web2 distributed approach. If I'm a common ordinary Web2 developer and I have a new project, then why will I make it distributed? Why will I allocate my code on many different nodes in the cloud? So the motivation, why distributed? First, I want to have fault tolerance. So I want my data to be replicated. I want to route computations to different services, to have redundancy and so on. So this is the first motivation. Second, I want to have everything I'm doing manageable. I want it to be maintainable, and I want to decouple life cycles of different parts of my service. So that's about decoupling and composition. And the common approach is microservices. So I can reuse microservices in different languages, I can wire them together, and so on. That's another motivation. Third, probably I want my application to be scalable and to approach the scalability in Web2 world in a distributed fashion. We have containers, we have metrics, and we have data grids, we have load balancing, and so on. So that's the third motivation. And finally, there is a number of cases when I want to do something distributed just to reflect a physical fact that something is essentially distributed. For example, Internet of Things, or mobile phones, or local networks. They are distributed because, for example, each person has his own laptop, so it's a distributed setup, or mobile phones, or name it. Another case is handling latency by geographic distribution with CDNs. So it's about the physical fact, and also it's about scalability. So that's why I want to be distributed. Cool. And why would I want to have something in Web3? So Web3, first of all, what is it? It's about being peer-to-peer, not just distributed, but more decentralized, more peer-to-peer, more permissionless. So the motivation for Web3, first of all, is economy and governance. It unlocks new ways to establish self-sustainability. It doesn't always mean to make money, but it means that you have the new ways to create something and to scale something, and that's important. And then after the economy, there are different properties that are also nice to have, and which actually make the Web3, like no single point of failure, no vendor lock-in. That's nice, and that's a property of a peer-to-peer Web3 permissionless. You cannot be locked. Or community involvement. If you build a peer-to-peer network, if you make it accessible to everyone, if you make it open source, then it means that you open the doors for creativity and the community can be involved. If you build another cloud or another API and so on, there's no incentive to be involved because we have so many cases when enterprises uses the community creativeness and then just closes the door. We know many cases like this, like bans of different applications for Twitter API usage or clones of software made by AWS and so on. So in Web3, that's by design. We have community involvement. That's nice. Also, we could have a physical fact of a local scenario when our scenario is essentially peer-to-peer, and we just don't need to have a central entity to be in between. One of the examples is FireChat. FireChat just reflects the fact that we are close to each other and we want to communicate. And we have some means of communication with like Bluetooth signal or something like that. And finally, we have values, more social values like censorship resistance, data ownership, and deplatforming protections. And these values become more and more important over the years. So this is the main motivations that I can identify to build my project, my brand new project, in a peer-to-peer Web3 fashion. And let's get back to distributed. Okay, if I want to make a new fancy backend for a Web2 application, and how I approach it, what's my mindset? First of all, I have a lot of experience. There are articles, software, it evolved over decades. But essentially, I have some problems or domains identified, and I have implementations of approach to these problems and domains. Like we have actor systems and implementations of actor systems like Aqua, my favorite one. But actually, you can think of services and microservices as an actor system done different way, but you can think like still in the mindset of actors. With actors and distributed setup, usually you have some kind of mailboxes. And for mailboxes, you have managed queues, Kafka, and so on to connect different parts of the application. You have persistence, and for persistence, you have many choices like key value stores, journals, write-ahead logs, different databases for any shape of data, and so on. Then for scaling and operations, you have Kubernetes. For service discovery, you have console, and generally speaking, you have DNS, and so on. And you have data centers, virtual networks for connectivity between them, some sidecars for connectivity like Istio and so on. So basically, I can decompose the problem of a distributed Web2 backend, and I know how to start, and I know why everything will be okay. And I don't need always to get everything, but if I take almost any approach, probably it will have some solutions for every part of that. For example, if you take actor system, then it has its own mailbox. For every actor, you have mailbox. You can switch on persistence and have write-ahead log. You can scale, and it has some primitive automatic scaling with Aqua. You can do service discovery with some small consensus algorithm or do a cluster. And you don't need to have virtual networks, but you can connect all these Aqua peers, for example, together, and to have the solution for the connectivity, like even without virtual networks. And you can choose what's more important in this case or in that case, and more or less everything is covered both with tooling and the mindset. And now let's switch to peer-to-peer. Okay, I have a motivation to go to Web3 and to go to peer-to-peer. And first of all, before I start developing anything, I need to consider the edge cases and to establish some constraints. I need to establish zero trust security. So with peer-to-peer, I assume that everyone in the world can send a message to my system. So there's no firewall that makes my cloud setup protected. The instances, like my services node, something should protect themselves. So this means zero trust security. And also this means that I expose many attack surfaces, which I have to consider from the beginning, like Sybil attacks, Eclipse attacks, double spending, and in the middle replay attacks, and so on. And I just have to care, because otherwise, if I'm just a bit successful, I will be hacked. And then I need to decide how to approach the discovery. And there is a huge choice. Usually in the peer-to-peer networks in Web3, if I need to discover something and if the peers are different, then I need to choose Kademlia and one of the implementations of Kademlia. If I don't need to have discovery, if I have a whitelist, or if I don't care where to connect, because every node, every peer, every service has the same state, like with the blockchain, then I need to live with that. This decision will last with me, and it will constrain me, like what can and what cannot be done. And when I consider security, then I need to switch to the second part with many questions which change the design, the system design of my network dramatically. Like what state is needed, and what exact state is needed, and how exactly I want to make it available. What guarantees do I need? What latency do I need? And so on. Then the question for my Web3 application, can it be deterministic? Will it contain some computations? And if I choose to be deterministic, then there is a question of oracles and how to provide data into the network, and that's a very hard problem. If I don't want to be deterministic, then the question is how to synchronize my peers. Do I want to have eventual consistency or no consistency, or how to approach it? And what's the right algorithm? At this point, I can think about the network algorithm. And then the question is, okay, I have these nodes, but what is the business model? How can I make the development self-sustainable, and how can I incentivize the community to to provide creativity, to commit into this Web3 project, how to distribute the tasks, and that's another question. And we have some solutions. For example, you can have inflation, or you can have mining reward, or you can have something like that. But for every solution, you have constraints, and there are not so many choices here, actually. And finally, after I considered security and I keep it in mind, and then I made a lot of decisions on the domain of my Web3 application, then I need to choose some tool or a tool set that matches my requirements. For some cases, there is a tool set, but for many, there's no. So, for example, if I decided that everything will be will have the same state, and I don't want to make a discovery, and I'm ready to be deterministic, then I can make a smart contract on a blockchain, for example. And that's one way that's open. You can do it. And we have a lot of different businesses around some smart contracts. Or you can move to layer 2 if a big blockchain like Ethereum is an overkill. And we have some layer 2 solutions like Substrate. But then we still have some questions, and it's hard to answer them in the current landscape of Web3 toolsets, like scalability. Okay, if we have Kademlia for service discovery, then it has some problems with scaling. It's not very trivial. It does match all the cases. If you decided to choose a blockchain, then you have a throughput that also limits the scale, and this throughput can be big, and different blockchains compete with each other for a number of transactions, and it's still not billions. You're still limited. And then the question, okay, I considered security, then I studied my domain. I got the requirements, and among the tool sets, I chose one that is the best available for me. Have I met the whys? Am I able to meet the motivation of doing Web3? Or I have to compromise? And what the compromise looks like? So often when the tool set cannot be in par with a Web2 distributed tool set or a mindset for a particular use case, then the whys can't be met, the whys of Web3, and the choice is actually Web2. And why is it bad? Is it bad at all? Is it good or bad? So when you don't meet, when you meet the why, then it has some outcomes, as it's a new approach that changes people's lives a different way than all the Web2 projects did. So it's a new wave, and when it works for a particular problem, when we really have this solution deployed, working, and so on, then we see that there is demand. Like we see crypto and how it evolves, because we have solutions for crypto. We have blockchains, we have smart contracts, we have tokens, we have governance, and DAOs is a completely new field. And I personally believe that it's huge and super important. And we have many approaches to DAOs and to governance. We have protocols like Compound, which are essentially smart contracts. We have some more centralized solutions like Snapshot to help you manage your DAO. That's essentially because we can do the DAO. We also have some community-driven networks, but not so many. And each one is quite specific in terms of the languages, algorithms, use cases, and so on. But I'm feeling that it's important to name some, like Aureus. Aureus is kind of awesome and radical. And it also means that the community as a whole can build some software that can compete with the old centralized setups, but also provide some new values. And that's why people go there and invest their time and effort to build it, if it's possible. And we have some more like IPFS. IPFS solves some problems somehow, but with no doubt it's around, and it's around because it proved that it's possible to make content addressable files because it's delivered the right way. And when you don't meet the why, you actually miss the opportunity. So to not meet the why, the easiest way is to not be able to solve how. And if you don't solve the how of Web3, how exactly to build your system, how exactly to approach your business opportunity, then there could still be an opportunity to create a Web2 business like SaaS. And we have some cases when we see that Web3 specific problems are fixed by centralized Web2 driven businesses. The most important example is Infura. It fixes some problems with Ethereum by providing a Web2 driven SLA. But in this case, you miss all the values of Web3. You have no community involvement into your core product, into your technology. It doesn't evolve. You're also the vendor, and you're locking in, and so on. Is it good or bad? I think neither. But I believe that in the better world, for every important problem in the emerging Web3 ecosystem, there should be a couple of Web2 solutions to Web3 specific problems, and a couple of Web3 solutions. And often we see that, for example, for Infura, we have Alchemy, right? And we have something like Pocket Network. And I know about a lot of different approaches to decentralize this Ethereum access, but with no luck compared to Infura, because it's very hard to build, to maintain, to evolve, because there are many questions how to do it. So would be nice to bridge the worlds. And what does it mean? It means that ideally we want to get wise both of Web2 and Web3. Why both? Because we are doing Web2 kind of distributed development in a distributed way. And we approach these distributed setups with a specific distributed mindset. And Web3 is essentially another kind of a distributed network. It's not closed, it's open, but essentially we still have this fault tolerance requirements, scalability, and so on. Why do I say so on? Maintenance, scalability, and geography, or something like that. So we want to have this still. but also to be Web3 specific and to get the opportunity of the new web. We want to get whys of Web3. Let's take a look on them again. Like no vendor lock-in, open source, censorship resistance, data ownership, deplatforming protection, and so on. And the connection to the new economy as well. That's important. And to do so, it would be nice to solve the house of Web3 in par with Web2. The problem of building a Web2 backend, a Web2 application, a distributed Web2 application is very, very well thought. So if we can leverage what we already have developed in this field, especially in theory, and solve Web3 specific problems somehow, it would be nice. And that's the approach of Aqua and Fluence. So Aqua approaches exactly this problem of filling the gap between Web2 and Web3, finally enabling Web3 in general, and enabling the businesses and the projects, the networks, the common goods of Web3, which do not evolve now because it's just too hard to solve all the problems in between. So Aqua brings some of the most common distributed practices into Web3 world. It provides microservices like actors like setup and brings it to decentralized peer-to-peer Web3 environment, solving many low-level problems and at current stage unlocking and making like much cheaper than before solutions to the middle layer problems, to get the product level solutions on the next step. Yeah, and then you can meet the whys of Web3. So how can we approach these problems with Aqua? First of all, we take the theory of Web2, especially P calculus, lambda calculus. We use signatures all around, and we build everything from ground up with security in mind. And this means that in many scenarios, when you had to keep security in mind just to get from the like blank page to hello world for your application, now you can focus on the hello world or on the application. That's super important. But it means that to provide the security and to fill this, to solve these fundamental problems, we need to begin with the new code base. We can use the well-known algorithms, distributed algorithms, but we need to implement them again just to have these properties achieved. So, for example, with Aqua, you can have discovery primitives. Like in Web2, we have many developed projects which evolved over decades or at least years, like console zookeeper or DNS. And a console means that you have a consensus based on raft. Consensus is essentially a raft algorithm and nothing more. And zookeeper is what? Paxos, right? It's also the algorithm, and both algorithms can be implemented in Aqua for non-global discovery, for application-specific discovery. But generally, Aqua and Fluence provides for Web3, first of all, Kademlia, and currently we are using the libp2p implementation of Kademlia, but we are going to switch. We are going to switch to Aqua and Marine implementation, the Fluence native implementation of Kademlia. We want to switch to our own implementation of Kademlia, not because it's fun, but because in this case, the community will be able to plug the custom logic into Kademlia and use Kademlia to form subnetworks for the particular products. So it lowers the barrier dramatically because you don't need to run your own network to have your own network. You can deploy a subnetwork on existing nodes, and you can prioritize the connections between these nodes over the general usage. We have registry. It's previously was known as Aqua DHT. Now we are going to switch to the registry name. It's like IPNS, but not exactly IPNS. So it's work in progress. Subnetworks is work in progress. Protocols is work in progress. And what does it mean that it's a work in progress? It means that we identify these problems and we understand that to get in par with Web2 and to provide the best experience for developers, we need to fill these gaps. And currently, we're more focused on the core implementation, on bringing these security primitives and so on, to make this possible and to make this stable. So if anyone wants to help us with anything like that, it would be nice. And I believe that some of these RIPs that I mentioned and that I will mention deserves to be a dedicated project or a dedicated maybe a business or a venture or something like that. It's an opportunity to build on top of Fluence network and to provide to the community. So let's continue. Currently, we have only Kademlia. We're working on all the other parts to get in par with the Web2 solutions. Next, about the state synchronization. In Web2, we have databases of any scale or any data shape, like we have anything. For Web3, it's much harder, but we have blockchains, big and small, of various shapes and different algorithms. And with Aqua and Fluence, you can proxy requests to blockchains. You can delegate state synchronization to blockchain if you want to. And it could be Ethereum. You can read from Ethereum. You can probably write to Ethereum if you want, or you can have a small dedicated blockchain for your smaller application over the subset of nodes. But it should be done. Another approach is IPFS plus orchestration. So it means that you can use IPFS to store files and to hash files and to access files and to transfer files. And you can use Aqua as a control plane to warm up the cache and to transfer files from the known destinations to another known destinations. If you have some knowledge from your application about where exactly the data is, then it becomes much more efficient to bring the data from that place to where you need it. Or there's space to make any other solutions using Aqua for control plane and some approach for storage. Aqua and Marine and Fluence provides access to the disk. Sandbox has access to the disk, to the persistent storage, more or less persistent, and often that's enough. What do I mean by that's enough? I mean that you can take this capability and add some algorithm like Raft built on Aqua to replicate the data. Then about APIs and logic. In Web2, we have a huge number of languages, frameworks, and we have a lot of open source and we have a lot of closed source, like REST APIs, different software as a service, and so on. And you can just build your application from that things in a Web2 world. And often that's the only thing you need to do, just to wire different existing APIs together. For Web3, everything is a bit harder because you know about the problem of blockchain bridges, for example. It's not trivial to get data from one storage to another storage if you consider a blockchain as a storage, for example. But with Aqua and Marine, you can access APIs and services from Aqua, and you can bring services, or you can bring existing code bases to this Web3 setup, which sometimes very efficient and like good. That's what we did with IPFS, for example. We brought the IPFS API or curl API to Aqua, and it can be reused in various scenarios with help of Marine, essentially. And for the new logic, for the new problems and new domains, or yeah, you can use Marine, our WebAssembly runtime, and to have you can have a security and portability of the code execution out of the box. So with Marine, you can run the code on the nodes. You can run the code on JavaScript. You can run the code on the browsers. We haven't released Marine Web yet, but now I'm pretty sure that it's very close. So the portability is here. Well, it kind of solves the problem. So you can bring existing code using effectors, or you can bridge the code, or you can develop the code with any language that compiles to WebAssembly, which is much harder but possible and doable. The next problem is operations and scalability. In Web2, we have a lot of tools like Terraform, Kubernetes, Docker, and so on. For Web3, it's time to replace Docker with WebAssembly. And with Marine, we have effects access with the help of WebAssembly because it's sandboxed, it's secured, and it's safe to expose the capabilities of the node to the outer world with WebAssembly. It's much more secure than doing so with Docker. That's why WebAssembly is so popular in Web3 world. And you can use Aqua for control plane. And if you have just running nodes, running Fluence nodes on the network, you don't need to redeploy nodes to compose, orchestrate, evolve, redeploy, update, and so on. So it's not exactly the replacement for Terraform, Kubernetes, and Docker, but it aims at the same problem. Then a couple of words about developer experience. In Web2, we have a lot of tooling to protect from from common bugs and problems. And usually this is critical, just super critical to have. For example, Aqua started untyped, but its development with untyped Aqua is barely doable. It's super hard. It's extremely hard, and not a lot of people can do it without the proper typing and the proper patterns. That's why Aqua evolved to typed actors and then to Aqua streams with actors inside, and they hide this essentially untyped experience of distributed programming with the types. We approach the same problem with Aqua. Aqua is typed, and it helps developer to avoid problems and bugs as early as possible. And it helps to debug programs and so on, debug distributed programs, distributed scenarios. So I believe that if we want to commoditize Web3 development, and if we want to make it accessible to people and to unlock the possibilities of these different businesses with the Web3 values, we need to provide the developer experience that is close to the solutions, to the Web2 solutions that aims on the same problem. And also, speaking about developer experience, distributed part is separated from computations, just like with the workflow management languages in Web2. And that means that you can reuse computations, you can reuse algorithms, and it's like much easier than do everything from scratch. Why it's important? Again, because with the tool sets for Web3 development that we have around right now, this separation of concerns is not done usually, and this means that you either take the whole stack with one language, with one set of libraries and so on, and live with that, or not. And it means that in this case, you can reuse algorithm despite the use case, the language choice, and so on. Okay, I have a small number of slides, and I will try to get faster. That's about maintenance and creativity. Web2 frameworks, ecosystems, microservices. For Web3, we need to have distributed algorithms as libraries, and we need to have composability on language level, and that's what we have with Aqua. And this means that you can distribute problems between different developers, and different developers with different interests and backgrounds can benefit from the stack and can add the value to the stack. So, and to wire everything together, we have WebAssembly interface types and Aqua instead of REST and GraphQL. Like the same problem, slightly different approach because a different domain. With Aqua and Fluence, you have Mailbox. Like in Aqua, for example, you have mailboxes in Web2, and if this is not enough, you can use something like Kafka or managed queues. For Web3, you can do you have the simple mailbox for every service on every peer, but it's kind of limited. Just like in Aqua, the built-in mailboxes are very simple. But with Aqua, you can do the more complex patterns like back pressure, polling, persistence, and so on. And probably the generic solution for this problem of mailboxes, well, it looks like a business opportunity on top of Fluence, because this problem can be solved, and it can be solved once for all, like it happened with Kafka. But the simple solution is already here with the service mailboxes. Then there is a problem of scheduler when you need to schedule the jobs and to distribute the workload among the peers. In Web2, we have a lot of solutions. In Web3, Fluence provides scheduler for Aqua scripts. It's very simple. It just runs some script recurrently, and it's in par with the most primitive schedulers of Web2, like the built-in Aqua scheduler, for example. More complex things to be invented. So it's already here as a fundamental solution, but needs to be improved at least. And for economy, for the connection with all the new economy, it's more about Fluence than about Aqua. But in Web2, when you begin the new project, you have a lot of options like SaaS subscriptions, application marketplaces. And for Web3, you also have some options like crypto, DAOs, or something like that. We want to implement some mechanics later as a part of the Fluence stack, but DAOs, if you have a DAO on some blockchain with a limited effort, you can connect this DAO to Fluence peers with like managed whitelist, for example, and that's Planet. That's not work in progress, but will be soon, and that's also important. So a few words about what Aqua looks like. If you don't know, you describe protocols, and like you can send some script. It flows from a node to node. It can call external APIs. It can get to another user, and it can reuse different protocols on the way. These functions, these protocols, has no need for central coordination, and it makes constitutes a single-use coordination network for every request. That's a tiny snippet of a hello world made trivial, finally, and running in a Web3 peer-to-peer fashion in 4 lines of code. So it seems very simple. You say that you want to call some function somewhere, and you want to get to this place through some relay. But actually, it involves all these signatures, different attacks protection, and all the stuff to make it trivial. Like it has a lot of complexity. In case you haven't seen Aqua book, and if you want to learn more about Aqua, take a look. Fluence is live. You have a dashboard which looks much longer now, actually, and we have a list of links. Thank you.